We're going to continue the mean value theorem. Yesterday, you guys played, or not played around, but like tried out a couple mean value theorem problems. You saw a couple Khan Academy videos related to that. And I just wanted to make sure we were okay with that before we moved forward. So in the black, we have f of x is equal to 5 minus 4x in the interval from 1 to 4. Notice that it's an open interval because they have the parentheses. In order to use the mean value theorem, we have to check just two things. Is it continuous in the interval? And is it differentiable in the interval? So I noticed that we have a rational function, and I know that rational functions tend to have a vertical asymptote, which would be a discontinuity. However, 4 over x has a vertical asymptote at x equals 0, which is outside the interval, so I don't have issues with the continuity for that. Same with the differentiability. If differentiability, I want to make sure I have kind of a smooth graph that doesn't have any sharp turns or a cusp. And if you can imagine what that graph would look like, you should be able to state that it is differentiable in that interval as well. So we can continue using the mean value theorem. Doing so means that we have to figure out what f of b minus f of a divided by b minus a. That's going to produce a number that we're going to use with our derivative. So that means in this instance, we need to figure out f of 5. F of 4. And we need to figure out f of 1. Okay, so doing those calculations in your head real quick, 5 minus 4 divided by 4, 5 minus 1 is 4. So I have 4 minus, and then I do 5 minus 4 divided by 1 is 1. Okay, that's kind of interesting. Over 4 minus 1, which is just going to give me a 3. So when I simplify this, I figure out that I end up with a positive 1. All right. So I need to keep track of this because this is important information. Now, the mean value theorem states that as long as these two conditions right here are met, then I am guaranteed that f prime, oops, got to turn off the highlighter, f prime of x should equal the number I just found, which is 1. I'm guaranteed at least one solution, so I'm going to go ahead and try and find it. So I know from doing my derivative work that f prime of x, the derivative 5 would be 0, so that goes away, equals negative 4 over x squared. And actually, it's not negative. It should be positive. Right? And if you're stuck, just pause the video and try to see how I got 4 over x squared so quickly as my derivative. All right. So now just doing a little bit of substitution, I can just do this. F prime of x should equal 1, so that means that 4 over x squared should equal 1. I do a little solving. I end up with 4 equals x squared positive and negative 2 should equal x. So there are my answers, right? Because if I plug in a positive 2 and I plug in a negative 2 into my derivative, I should get my slope of 1. However, the mean value theorem states that my answer should be in the interval that I located. And the interval that was given to me was 1, 4. So, according to the MVT, my answer should be that x equals 2, but we're going to call that c because that's the variable they use to distinguish it from x. Let's talk about this specific situation. And that's it. The negative 2 is not in the interval. Oops. So I don't use that. And that's how I use the mean value theorem. But I also want to make sure that we're okay with some word problems because that's what we're going to focus on a little bit tomorrow. So as long as you know how to follow these steps, which is just check the initial conditions of is it continuous, is it differentiable in the interval, figure out f of the difference between the y values of the intervals over the difference in the x values of the interval, take your derivative, set it equal to that number you find, solve for x, and then take the answers you find and make sure that you choose the value or values that are in your interval. Okay. So now let's try this one out. Two stationary patrol cars are equipped with radar 5 miles apart on a highway as shown in figure 314. As a truck passes through the first patrol car, its speed is clocked at 55 miles per hour. 4 minutes later, when the truck passes the second patrol car, its speed is clocked at 50 miles per hour. Prove that the truck must have exceeded the speed limit of 55 miles per hour at some point during the 4 minutes. Okay. So, interesting. So we're talking about speed. So, the way I see it is this is a continuous graph because if I think about how a truck would move, it's just going to keep going. It's not going to stop. It's not going to have like some weird jump. If you can imagine what the graph would look like that's not going to happen. It's just a very normal graph. Okay? And it's differentiable because, I mean, you wouldn't really expect the behavior of the truck. Oops, sorry. Right? If I had something like this, where I have some sort of like cusp, notice how it's like a curve, but it reaches a sharp point. That's the cusp, or two straight lines kind of meeting. I wouldn't expect this kind of behavior from the truck because I mean it's set 55. Then it turns out to be 50 miles per hour. Like it's not going to have those sharp turns. That's not how the truck should operate. So we are meeting the initial condition, albeit not mathematically at this moment, but it's there. So here's what I know. 4 minutes is equal to 1/15 of an hour. All right. So essentially, we're looking at the interval of 4 minutes to 1/15 of an hour. Notice how I'm careful with my units because they're talking about miles per hour. Miles per hour. So I got to make sure my time is in hours. All right. So according to the mean value theorem, since I've met the condition for it being differentiable and continuous in the interval, I can go ahead and get started with the slope. So f of 1 15th minus f of 0 over 1/15 minus 0. All right. So they told me that in 4 minutes it traveled 5 miles, which means that in 1/15 of an hour it traveled 5 miles. So that means I have 5 minus 0, because I'm assuming that like right here where it started at a 0 position. Then over here at 1/15, it had traveled those 5 miles, right? And then simplify that, so I get 1/15. So essentially, I have 5 divided by 1/15, which comes out to 75 miles per hour. And if you're not sure how I got that, just work through, and if you type this in a calculator, make sure you type it in like that, because you're dividing by 1/15 of an hour, not by 1 and then by 15. Okay. So, if that's the case, then according to the mean value theorem, I know that the mean value theorem states that f prime of c should equal f of b minus f of a over b minus a. So because I found this value here, that's what I have for this part. I know that in between this interval from 0 to 15, there should be a time where the speed was 75. And that's all you really have to do with it. You have to make that analysis, right? So if you had to write this out in a word problem, what I'm saying is what you would write down. According to the mean value theorem, since the average speed was 75 miles per hour between this interval right here, the mean value theorem guarantees that there is some time inside this interval where the speed would have to equal 75 miles per hour. And that's all you have to do with this.